Hello and welcome. In the world of machine learning, we're always chasing perfection, right? We want a model that gets every single answer right. But what if I told you that a perfect score can actually be a massive sign of failure? Today, we're going to dig into one of the biggest challenges in all of AI, the overfitting problem.
So let's just jump right into that question. How on earth can a perfect score be a bad thing? It sounds completely backwards, I know. But if you stick with me, you'll see that understanding this paradox is the absolute key to building AI that actually works out in the real world.
And to get to the bottom of this, we're not going to start with code or complex math. Nope. We're going to start with a simple story, a tale of two students who are getting ready for a big, important math exam. Their study methods are totally different, and the results? Well, the results are going to tell us everything.
Okay, so meet our students. You've got student A. This student is diligent, right? They study the core concepts, they practice the different methods, and they really work to understand how to solve the problems. Then you have student B. Student B finds a shortcut. They manage to get their hands on the exact answer key for the practice exam, and they just memorize every single answer, one by one.
And here we go. The results from the practice exam are in. Student A, the one who really learned the material, does great, on 95%. But student B, the one who just memorized the answers, a perfect 100. So just looking at this, you'd think student B is the star pupil, right? The clear winner.
But here's the real test, the final exam. And on this exam, all the questions are new. The numbers are different, the problems are worded just a little bit differently. So who do you put your money on now? The student who learned the how, or the student who only memorized the what?
Obviously, that story isn't just about passing a math class. It's actually a perfect analogy for how a machine learning model learns. So let's translate this little story directly into the world of AI.
And this table just lays it all out perfectly. The student, that's our AI model. The practice questions, that's what we call the training data that we feed to the model. And the final exam, well, that's the real world, new, unseen data that the model has never encountered before. And here's the most important part. Learning the methods, that's what we call generalizing the pattern. That's the goal. But memorizing the answer key, that's called learning the noise. The noise is just all the random little details in the practice questions that aren't going to show up again. It's totally useless information.
And this brings us to the official name for student B's problem. This whole scenario is what we call the overfitting trap. And it's something data scientists are constantly fighting against.
So here's the official definition for you. Overfitting is what happens when a model learns its training data too well. It doesn't just learn the important underlying pattern, it also starts memorizing all the random, irrelevant details, the noise, which is exactly what student B did, right? They memorized the answers instead of the actual problem-solving method.
It all comes down to this one critical difference, this one huge battle, memorization versus generalization. Does your model just take a perfect snapshot of the past, or does it actually learn a lesson from the past that it can use to navigate the future? We are always trying to get it to do the second one.
So, an overfit model has some classic telltale signs. It has basically memorized the training data, which is why it gets that super high score there. But because it's so rigid, it completely falls apart when it sees anything new. In the lingo, we say a model like this has high variance. You can think of it like a really jittery, nervous student who overreacts to every tiny, insignificant detail in the practice questions. It ends up fitting itself to all that random noise instead of the real stable pattern underneath.
Okay, so we know what overfitting is now. But how do you actually spot it when it's happening? In the real world, how do you know when your model has crossed the line from learning to just plain memorizing?
Well, there's a really clever trick. While you're training your model on all those practice questions, you actually hold back a separate set of questions. This is called your validation data. Think of it like a series of surprise pop quizzes. The model never gets to train on this data, we just use it to check in and see how it's doing. And by tracking its performance on both sets of data, we can see the exact moment it starts to cheat.
So, in the beginning, everything looks awesome. As the model trains, its error rate on both the training data and the validation data goes down. You can picture two lines on a graph, both trending downwards, nice and happy together. This means the model is really learning the general patterns. It's working.
But then you hit this critical point, this moment of divergence. The model's error on the training data keeps going down. It's still acing its practice test, getting better and better, but the error on the validation data, on those pop quizzes, suddenly U-turns and starts to get worse. This is the smoking gun. This is the moment you know the model has stopped learning and has started memorizing junk.
And this quote right here, it perfectly captures that alarm bell moment. The validation loss will hit a minimum and start to increase even while the training loss continues to decrease. Loss is just another word for error. When you see those two lines on the graph split apart like that, one going down, the other going up, that is the classic, undeniable signature of overfitting.
So as we start to wrap this up, let's just bring it all back to that one central challenge, the thing that really defines whether a model is a success or a failure.
At the end of the day, there are two paths. You have the path of memorization, where the model learns the noise, looks perfect on paper, but then fails miserably in the real world. And then you have the path of generalization, where the model learns the true pattern and actually succeeds out there when it matters. Our whole job is to guide the model down that second path.
Because you have to remember, the goal isn't to get a perfect score on the data you already have. Who cares? The whole point of building these things is to create something that's useful, something that can make accurate predictions on new problems it has never seen before. That is the final exam.
And that leaves us with a really interesting final question, doesn't it? If we know a model will always take the easy way out and cheat by memorizing if it can, how do you actually design things to force it to learn? How do you make it study the methods instead of just cramming for the test? Well, that's the real art and science of building intelligent systems. Thanks so much for joining me.